Hey everyone, welcome back. Today we're going to look at determining the equation of a quadratic function with given information. If you've completed the previous quadratic videos that I have in the Pre-Calculus 11 series, today's lesson will be a lot easier for you. So let's dive right in. Example 1, determine the equation of the quadratic function. So A, what's being given to us? A vertex at minus 2, 2, and an x-intercept at x equals negative 3. So we have standard form of our function, a times x minus h squared plus k. And since the vertex is at minus 2, 2, we know that k is going to be 2, and then h is negative 2, which makes it plus 2 like that, right? What do you plug in to get this to be 0, right? We saw that to get your vertex. So this is our updated equation. The only thing that's missing is the a, right? This is our function here. What's missing is the a. So we're going to look at our x-intercept here. And so x equals negative 3. That means the point negative 3, 0 is on the graph. So we can plug that in and it'll be true that it belongs there. So what this means is we can plug in x as minus 3. The entire function is equal to 0, right? That's our y value. And now we want to isolate for a. So we got a times minus 1 squared equals negative 2, which gives a equals negative 2 like that. And so here we're going to update our equation so that the function is negative 2 times x plus 2 squared plus 2 like that. And so this is our equation. B, vertex at 3, negative 9, y-intercept at 0. So this means using the standard form that we plug in 3 and it gives 0. So x minus 3 squared like that. And then this is minus 9 as such. So now we just need to find our a. Since y-intercept is y equals 0, we know that the point 0, 0 is on the graph. So we're going to plug it in, which gives us 9a equals 9, which gives a equals 1. And so here is the equation of our function. Okay, practice number 1. Determine the equation of the quadratic function, a, b, and c. Go ahead and pause the video and answer that. Okay, we're back. So a, vertex 2, negative 1, x-intercept at 3. So because of our vertex, we know it's x minus 2 squared minus 1 like that. X-intercept x equals 3 means 3, 0 is a point on the graph. So we plug that in here. And then this gives us a equals 1. So we update our equation so that our function is x minus 2 squared minus 1 like that. B, vertex minus 3 minus 4. So our function is x plus 3 minus 4 like that. Y-intercept at negative 13 means 0, negative 13 is a point on the graph. We plug that in, x equals 0, y negative 13, and this gives us a equals negative 1, like that. So we have negative times x plus 3 squared minus 4 as our function. C, vertex 4, negative 3, so our standard form is x minus 4 squared minus 3, like that. We don't know a, but x-intercept is x equals 7, meaning 7 comma 0 is a point on the graph. So we plug that in, x equals 7, y equals 0. This gives us a equals 1/3. So our function is 1/3 times x minus 4 squared minus 3. Okay, example number 2. So determine the equation of the quadratic function. Here they're giving us these 3 points, 0, 9, 1, 0, and 3, 0 like that. So what we know is when we're looking at these 2 points, they have the same y value. Therefore, the axis of symmetry is in the middle of those 2 points. So 1 and 3, so 1 plus 3 divided by 2, the middle is 2, like that. And so since that axis of symmetry is x equals 2, we know that the vertex is going to be at x equals 2. So here we have that. We can update our equation here, a times x minus 2 squared plus k like that. So now we have 2 unknowns. We have k that's unknown and a that's unknown. We do know that point 1, 0 is on the graph. So if we plug in x equals 1, y equals 0, we can isolate for k, and that gives us negative a. So instead of writing plus k here, we're going to write minus a, right? You see how we did that? We replaced it, instead of k, k is minus a, so we write it there. And so now we have a function with only one unknown. So we're going to plug in a different point, so say 0, 9, that is on the graph. X equals 0, y equals 9. This gives us 4a minus a, gives us 3a equals 9, a equals 3. So f of x is 3 times x minus 2 squared minus 3, like that. All right, so we got the 3 from here and also the minus 3 like that. Okay, B. Same question. We got 3 points here that are on the graph. These two have the same y values. So we know that the axis of symmetry is in the middle. So minus 3 plus 1 divided by 2 is minus 1, like that. So we update our equation, x plus 1 squared, like that. So we have a and k that are unknown. 1 minus 5 is on the graph, so we're going to plug that in. X is 1 and y is negative 5. This gives us to isolate k as negative 4a minus 5. So we're going to update our equation here. If instead of writing k, we're going to write minus 4a minus 5, like that. So now we have only a as one unknown. We're going to plug in a different point on the graph, 3 comma negative 11. So x is 3, y is negative 11. This gives us 12a equals negative 6, so a equals negative a half, like that. And so this negative a half isn't just the a here, but it's also the a here, like that. So we plug that in, and this gives us minus 3 for this component right here. So negative a half times x plus 1 squared minus 3 is the equation of our function. Okay, practice number 2. Determine the equation of the quadratic function. So we got 3 points that are on the graph, and B, another 3 points that are on the graph. And so go ahead and pause the video and answer that. Okay, A. So we have these 2 points, same y values. So axis of symmetry is in the middle. 2 plus 6 divided by 2 gives 4. So 4 is in the middle. So we update our function here, x minus 4 squared, like that. 2, 0 is on the graph, so we plug that in, x equals 2, y equals 0. This gives us k equals negative 4a. Replace k with negative 4a like that, so now we only have one unknown a. 0, negative 12 is on the graph, so we plug that in, x equals 0, y is negative 12. This gives us 12a equals negative 12, so a equals negative 1. So we plug in negative 1 here at this a, and also the minus 4a here as well to give us plus 4. Okay, B. These 2 points have the same y value, so the axis of symmetry is in the middle. So minus 2 plus 0 divided by 2 gives negative 1, like that. So here's our updated function, x plus 1 squared. 0, negative 1 is on the graph, so we plug that in. X equals 0, y equals negative 1. So we get k equals negative a minus 1. Instead of writing k, we're going to write minus a minus 1. So now we have only one unknown a. 1 comma 5, sorry, is on the graph, so we plug that in. X equals 1 and y equals 5, like that. This gives us 3a equals 6, which is a equals 2. And so we're going to plug in 2 into here like that, and plug in 2 into here to get minus 3 like that. And that's it. It's that easy. I'll see you guys in the next video.